Now we are going to investigate photon size further using multiple slits. The slit we are using now is made from aluminum sheet glued to a slightly larger plastic sheet. Regularly spaced straight cuts were made using a knife to create gaps between aluminum stripes. The distance between the gaps is 5 mm, and the width is less than 0.1 mm. That almost no aluminum is removed from the sheet. The gaps were then filled by plastic glue so each aluminum stripe is electrically isolated from its neighbor. When the stripes are oriented horizontally, some amount of microwave can still pass through it, but when oriented vertically, the microwave is completely blocked. The next experiment will use the same aluminum sheet which was used previously, but the slit density has been doubled. Now the distance between the gaps is 2.5 mm. Compared to previous experiment, the reading shows significantly higher value when the aluminum stripes are oriented horizontally. When oriented vertically, the microwave is still completely blocked. Note that the aluminum sheet covered almost entire area in the transmission path of the microwave, but the receiver can still get most of the transmitted wave when the stripes are horizontally oriented. In contrast to previous experiments, now we will use multiple slits whose gaps are much wider than the conductor itself. Here we use copper wire strands glued on plastic sheet. The diameter of the strands is roughly 0.1 mm, while the distance among them is 10 mm. When the slit is oriented vertically, it can block some of the microwave. When it is horizontally oriented, only small amount is reduced. The microwave can be reduced further when the slit is not perpendicular to the transmission path, so that there are more conductors stand in the way. We can add another slit to cover the transmission path with more oblique angle to have more conductors interacting with the microwave. In the next experiment, we will show the effect of distribution of conductors in a multiple slit obstacle on microwave transmission. We will use stranded wire glued on a plastic sheet. On one side of the slit, the wire strands are clamped together with 10 mm space among them. On the other side, the wire strands is spread apart to cover more area of the sheet. Note that the number of wire strands is the same for both sides. With clamped side, the receiver still gets significant amount of the microwave, but when the other side is used, the reading shows 0. Now we will use two metal gratings for the next experiment. The width of the gaps are 20 mm, while the diameter of the conductor is 2 mm. When both gratings are aligned, the reading shows that the receiver still gets most of the transmitted microwave. But when the gratings are interlacing, the reading drops to less than half scale. From the experiments shown in this video, It is clear that photon model is not the best way to describe microwave interaction with electrically conductive materials. We need a better model based on following facts.